Hello everyone, this video is about the work energy theorem. Let's remember the concept of work and deduce the work energy theorem step by step. Alright, so before we start talking about the theorem itself, let's remember what is net work. Well, the net work is the sum of work done by all external forces in a system, alright? So we can express generally the net work using this formula here, where we have the net force times the cosine of the angle between the force vector and the displacement vector, and the variation in space or the displacement, okay? If we plot a graph like this, force versus space, we have a line like this, right? And this area below this line is exactly the net work. If we want to calculate this area, we can make infinitesimal displacements here, ds, and sum all these small areas here to get the net work. And that's exactly what an integral is. So the net work can be the integral of the force times the cosine of the angle times ds. Okay, so let's start now with the work energy theorem itself. Okay, let's consider for some reason we want to push a block at a certain distance. Okay, so we have a displacement of delta s here. Let's take a look into the forces that are acting on the system. So we have the weight of the block, right, pointing down. We have the normal force that's pointing up, perpendicular to the surface. We have the friction force, and we have our net force because we want to push it further, right? Okay, so if we use the definition of work, we have that the net work is this net force here times the displacement, okay? However, we know that the net force is the mass times the acceleration of the block, so we can just add this into our first equation, okay? We can keep going further and remember the Torricelli's equation, okay, that relates the final velocity with the initial and acceleration times displacement, okay? We can just isolate the acceleration for this formula and now add this acceleration in our net work formula. So we end up with this formula here. So see that we can cross these two displacements here and find this final equation. See that this part here, half of mv squared, is actually the kinetic energy. And that's exactly the work energy theorem. We are relating the net work with the kinetic energy. See that for this formula here, we do not depend on the displacement, nor the weight of the block, nor any external forces, friction. We just depend on the mass and velocity. And from this formula here, it opens us lots of possibilities when solving problems, okay, mechanical problems. From this thing here, we can find, for example, the displacement, the net force, the friction force, the final and initial velocities, the net work. So because of all these relations here we've seen before, it opens us a lot of possibilities. So let's go now and put it to practice, okay? So you'll see how much easier it will be to solve problems using this theorem. Okay, so for our problem, let's consider the same system, okay? But now we are adding values. Okay, we have a mass of 20 kilograms, a friction force of 2 newtons, the displacement will be 1 meter, the force is 100 newtons, the force that we're applying to move the block, okay? we want to find the final velocity for this. So let's consider that the initial velocity is 0 and that the final velocity is the thing we want to find. We can start by the network, okay? So we can just use that network formula to find the work first. So we have that our net force is the 100 newtons minus the 2 newtons, the friction force, and the displacement is 1 meter. It gives us a net force of 98 joules. Okay, so from here we can apply the work energy theorem. So we are relating the network with the kinetic energy. So from here we have everything we need. So we know that the V0 is 0. Okay, we have the mass and we have the network. We can just isolate V and find that the final velocity is 2.56 meters per second. So see how much easier it is to find the velocity using the work energy theorem. We didn't need to calculate any of the other forces, any accelerations, all right? Just find the network and then straight the velocity, the final velocity, okay? So a question I have for you now, can you solve the same problem but just using the Newton's law? If you can solve it, think how you're going to solve it just using Newton's law and write your answers in the comment section.
Physics can be easy. Subscribe to our channel and learn with the geeks.